Hi guys, BuildZoid here, and today we're going to be taking a look at this monstrosity right here. So this is my latest and most successful e-power ever. This is a GTX 480 reference card, yeah, I've upgraded the VRM. Right now it's on the Thermalright Shaman heatsink, which I gotta say I'm really glad I got my hands on this heatsink because it's freaking awesome. And the reason, well, freaking awesome for like this kind of situation because look at that clearance. Right? Like, it's great. I can fit an e-power under this heatsink. And yeah, that's just not possible with a lot of other aftermarket heatsinks. It's far more convenient. Like, the thing I love about aftermarket heatsinks like this is they're far more convenient to use than, like, well, full cover water blocks are just inconvenient in general as far as I'm concerned. Like, yes, I know that's great cooling performance, but too many screws, heavy, expensive, fit only one card, obviously don't fit if you do this. Universal water blocks are good, but unless you have quick disconnects in your water cooling loop, they're still kind of awkward to deal with, and water cooling loops tend to be kind of bulky. Then the Morpheus heatsinks, well, those don't have all of those issues, but they don't clear e-powers. So I'm really glad I got my hands on one of these, because Thermalright doesn't actually make them anymore, so the only way you can get them is like eBay, secondhand. And I actually got this heatsink, like it wasn't listed as somebody selling this heatsink. They were actually selling like a GTX 480 that they had with this heatsink on it. But I just wanted the heatsink, so it was like, yeah. And this is exactly why I wanted that heatsink. Is just, it's perfect when you're e-powering a card like this, because that clearance, right? Like that is awesome. And the best part is this actually, like the thing that, well, the thing is these big aftermarket air coolers like this one, they actually have really good cooling performance. They're roughly on par with what you'd get if you like zip tied an AIO to a GPU, like say a GTX 480. So this actually, when I was testing this card, I was just running some Firestrike just to get an idea if, you know, this is working as intended. And yeah, it is. The card still goes up to the same clock speeds that it did before e-power, which was 969 megahertz on the core, so it still does that. I almost did 980 megahertz, but I think I ran out of cooling headroom because it was crashing. Like GT1 would finish, and GT1 is actually the more GPU core heavy workload, but GT2 was crashing, and I assume that's just by the time it got into GT2, it was too hot. So yeah, that's kind of the thing. But anyway, like in the testing when I was running the 969 at like 1.25 volts on the e-power, you know, this thing was hitting, like, it was holding under 60 degrees Celsius. Now, admittedly, my room is around 20-something degrees, so, you know, it's not as, like, it's not the same kind of, like, if your ambient is 10 degrees higher, then the temperature would be 10 degrees higher. But still, you know, holding 60 is pretty good, especially because I am on the Corsair TM30 thermal paste, and this stuff is well, on something like a GTX 480 is not ideal. It's okay for low heat load applications, but like really I would expect maybe a 5, maybe 10 degree drop if I actually used a proper thermal paste instead. But the thing is, it was just rough testing, right? So I just needed to know if this works, and it does work. So that's pretty great. So that's the heatsink on there. And now let's talk more about the e-power. So e-power is, like, I think it's the coolest vault mod out there because it's by far the most difficult, I'd argue. And it's not really difficult from, well, there's some fiddly things related to like, getting the card actually functional under e-power. But the thing is, it's just like, well, it's the most involved modification and most extensive modification, because basically what an e-power is you replace the stock VRM with a bigger, better VRM. Yeah, and that's why I think it's the coolest modification out there, because it really doesn't get more better than just replacing the entire V-Core VRM. So this being a reference GTX 480, this normally has a 6-phase V-Core as its stock power delivery. And it's not a bad 6-phase. As far as 6-phase VRMs go, you could do a lot worse than what a reference GTX 480 has for its 6-phase, but it is still just a 6-phase, whereas this is a 14-phase V-Core VRM, and this is the same 14-phase that you would see on like a GTX 580 classified, GTX 680 classified, GTX 780 classified, GTX 780 Ti classified, GTX 980 classified, 980 Ti classified, 1080 classified. So EVGA is very, very proud of this VRM because they designed it once and it's so good that they never bothered to redesign it again until like the 10 series, where, yeah, like the 1080 was the last card to still use this VRM design. Now, the controller does actually change between GPU generations because the controller, like this is a CHL 8318, and the 8318 doesn't support some of the new voltage regulation standards that some of the later NVIDIA cards require, but basically the actual like driver, MOSFET, inductor, capacitor configuration hasn't changed for, well, basically from the 580 all the way to the 980 Ti, because this is just such a great VRM. So yeah, it's a huge upgrade over what like a reference GTX 480 normally has for its power delivery, and you know, much more efficient. And the thing is, I really do want to take a GTX 480 on liquid nitrogen. And the other thing is with the e-power, like this is a really difficult modification that I've attempted multiple times, but I've only really had 2 successes with. Which one was a GTX 570, and that was still with this red e-power, and that card had major issues. The connection was really crap, so I was losing a bunch of power just in the actual soldering and the wires. And the end result was that, like, if I set 1.6 volts on the power card, I was getting like 1.35 to like 1.4 at the actual GPU core. So that was atrocious because it was losing so much power getting to the actual GPU that, you know, I was on liquid nitrogen and it was just not really that great. But this doesn't lose anywhere near as much power. When I did checks on this, well, I don't know how much power loss there is in the power plane of the PCB itself. So fun fact, a lot of GPUs have relatively, it's not as bad as with motherboards, but motherboards are really bad. Like you have huge voltage drop from like the CPU proper to the VRM. But on GPUs, you still, depending on the power plane of the GPU you're looking at, you do have a pretty significant voltage difference between like the output of the VRM to the actual GPU core. So, you know, I didn't actually check what the situation with that is here, but still, like, at least going from the power card to like the output filtering capacitors on the 480 itself, I'm not seeing a huge amount of voltage drop. So I'm pretty happy because that tells me at least the main connection seems to be pretty good. So yeah, that's kind of the thing, is just like you need to get a good connection, and that's quite difficult because my past, well, the funny thing is like some of my attempts wasn't so much like the connection was bad. It was like, so first successful e-power for me was a GTX 570. Then I tried an R9 290X, but unfortunately the R9 290X had a grenade, like that card was used for a bunch of other modding in the past. And like, if I remember correctly, at some point that card had a completely screwed up feedback circuit for the voltage controller. So by the time I e-powered it, it actually turned out I had probably like destroyed the core because that card could not install drivers no matter what you did. So yeah, like that card was just like, okay, the core was dead. Then there was I have a R9 290 that is in progress. Oh no, wait, there was a GT710 or something. No, GT730 that I e-powered, and that was fine. That actually ran just fine. That like, other than the fact that the card sucked for some reason in benchmarks, it actually, like, that worked. But that's a low power card. And the thing is like with the e-powers, like I really want to move up to e-powering things like a GTX 590. That's been sort of that's been a goal for me for a very long time. I've just not worked on it because I'm like, GTX 590s are difficult because you're basically trying to power the equivalent of like 2 of these. And so you have to deal with, well, you have far more voltage regulators that you need to override. You also, like, the connection is much more difficult to do. The GTX 480 PCB is actually really well laid out for doing something like this because let's just grab some tweezers, because basically you have this lovely, very, like, there's this ground strip right here where there's a whole bunch of vias, because this is actually the ground strip used for the output filtering capacitors of the stock VRM. So this actually, like, the big issue with grounding e-powers is because, like, the connection basically goes V-core to V-core, ground to ground. But the problem with the ground to ground connection is that, for example, screw holes, right? Screw holes are ground, but the thing is they're ground in sort of like name only. They're not meant for power transfer. So if you try to ground off of screw holes, you're going to find that you might have very, you know, like, this is 12 standard wire gauge wire. So this is really fat. It's like 10 AWG. It's solid copper. can handle a ton of current. Like if you use this kind of super fat wire and you just hook it up to something like a screw hole, you're still going to have a ton of voltage drop because the connection from the actual PCB's ground plane to the screw hole sucks. It's there, but it's not really like a really high integrity connection, so it can't really carry a lot of power. So one of the big issues is with cards is just finding, you know, ground points. And obviously if you try to ground off of like, I don't know, like let's say you find a ground strip that's like this area of the card back here. Well, then your power is going to have to do a silly sort of, you know, it's going to come out of the inductors over here, and then it's going to go into the core, and then it's going to go through the core, and then all the way back to wherever you put your ground connections on the end of the card. Like, you're going to have a bunch of voltage drop again. So with a lot of cards, a big part of it is just finding ground connections that don't suck. Right, and output filtering capacitors are really great. So, like, you know, that's like this ground wire right here that goes to the ground of this capacitor over here. These are actually just more V-core, these red ones. So those just go to the V-core of these output capacitors as well. These are kind of unnecessary, but it was just like, I have spare wire lying around on my desk, so might as well use it. So, yeah, but the thing with the GTX 480 is you really do have a really nice just ground plane right here. Tons of vias for power transfer, so great place to grab your ground from. Then the only issue is that the red e-power, the e-power classified from EVGA I'm using, it doesn't have a front ground, like a intentional front ground. So you basically have to ground off of the grounds of the capacitors of the e-power. But yeah, this actually, like, this connection seems to work really, really well that I've made. The connection for V-core is literally just a, like, massive blob of solder. So if we zoom in on that, right? Like, there's no actual, nothing, like, this is literally just a solder bridge going from the V-core strip of the e-power to the V-core plane of the GPU. And that works actually just fine. It's a really nice connection because, you know, very short, very large cross-section, so it doesn't have a lot of voltage drop because it's very low resistance. The ground connection is just like, just use as many wires as you can physically fit, or when you get bored of adding more wires, right? So that's how we ended up with that. So yeah, I'm pretty happy with how the connection worked out on this, but on a lot of cards, like, this is far fiddlier. For example, like 290Xs, for example, you have, instead of having like ground and V-core, you basically have, lands of V-core and then lands of ground. So there's little islands next to each other. So you have like ground, you have V-core, ground, V-core, ground, V-core, ground, which is, I assume, it has some kind of benefits for your output filtering capacitor layout and that kind of thing. Or it's just more convenient, or like, there's a reason why you lay it out like that instead of like what the GTX 480 has. But the thing is just like, when you're dealing with that, you really need to, like, it's awkward because you'd be doing like, okay, so here we have some V-core wires, then next to that you'd run your ground, then next to that V-core, much more, you'd have to be much more accurate with your soldering than what I did here, where, yeah, and that gets annoying because when you're soldering power planes, they soak up a lot of heat, like an absolute ton of heat. So this is the solder, right? Zoom out. This is the soldering iron I use for basically doing all the main connections. I do also have two little 60-watt irons, and what I actually do for the grounds, like for the big solder blobs for V-core, I just use this directly. Like, there's nothing else that I can really use for that, because a 60-watt iron isn't going to even it's not going to do anything. But with the ground wires, what I would do is I'd sort of tack them on with the little 60-watt, and then I'd fix actually get the connection proper with this big 150-watt soldering iron. This is meant for like copper piping work, but you might be like, so why do you use that? Well, when I first wanted to do an e-power, I basically realized my soldering iron just doesn't have a chance of doing anything for this. So I asked Der Bauer what soldering iron he recommends for using this, because he's actually been doing, you know, e-powers for far, far longer than I have. And he's been overclocking for far, far longer than I have. But yeah, back then, you know, I asked Der Bauer, what soldering iron do you recommend? And he was like, get this. And so, yeah, that's how I ended up with this thing. And yeah, like, the biggest issue with it is it's heavy. So, you know, it's not very accurate, and you really have to pick your battles with it, right? Like, you're not going to be trying to solder small details with this because you're just going to fail. But it does work really, really well, right? Because it does have a ton of power, so it works great for this kind of thing. Even though, like, yes, the soldering is really ugly, but there's no voltage drop. The connection is nice and solid, so I'm happy with that. What else is there? Oh yeah, for structural integrity, I have this brace right here just to keep the e-power steady. This isn't meant to ground. Like, it is going from a screw hole, so that's ground, to another screw hole, so that's also ground. But this is really there just for structure, not for like power transfer or anything. That's really just all of this ground right here, and then that orange wire there. Similarly, I have another wire over here because the thing is, this is so. Like, this is now so, because of all the metal that I've added in this area, as well as the e-power itself, like that heatsink's not light, the inductors aren't light, the whole thing is actually kind of heavy. The thing is, like, the whole PCB is actually kind of has a tendency to flex that way at this point, so I added this to sort of reduce that to some extent, because, yeah, I'm not really a fan. Also, when you plug in all the wires into it, it just wants to, you know, bend the card as well, so this is here to try keep the card more straight. That's all that's for. That's not, you know, it's not for power delivery or anything. It's just like, yeah, I want the card to stay still and not bend so much. So, yeah, that's kind of that. Now, in terms of the sort of fiddly electronics thing, so one thing with e-powers is like, GPUs will actually complain if you don't plug in your 8 pins and your 6 pins. So what I've done here is we have this yellow wire which jumps the 12 volts from the 6 pin to the 8 pin because I actually just use a daisy chain 8-pin 6-pin connector from my PSU when I'm running this. So, you know, I have just an 8-pin like, well, fun fact, these 6 pins are ground, these are 3 ground, 3 12 volts. So by spec, they're actually the same power delivery capability as a PCIe spec 8-pin, because normally an 8-pin is 3 ground, 3 12 volts, 2 sense lines in an 8-pin. So that's why like 8 pins actually are, they don't actually have that many power pins in them relative to how many pins there are in total. And 6 pins are actually 2 ground, 1 sense, 3 12 volts. But this is 3 12 volts, 3 ground, so this actually has the same power delivery capability as like a GPU's 8-pin, but it's not a GPU's 8-pin. The reason why this is done is because this doesn't support, like, well, the sense pin in the normal PCIe cables is actually meant for a hot plug functionality, but I don't know. I've never seen that actually like used. I guess it's mostly for server applications. But yeah, because I've never seen anybody actually never seen a card that actually takes advantage of that. But yeah, this doesn't support that at all. Basically, if you don't plug in all 3 of the power connectors, this doesn't turn on. So that's how that deals with that. But yeah, so, you know, plug these in, and then I just run a daisy chain extension to this 6-pin, and that 6-pin then feeds the 12 volts over here. These solder blobs are there just to short out the sense wires. I could actually, if I wanted to, I could make this card run entirely off of the PCIe slot if I just ran another wire to the 12 volt PCIe connection, but I decided that, you know, like, if I was dealing with, if it was like I did an e-power before, where e-powered a GTX 480 before, where I also had another power board for the memory VRM, and there that was a nightmare because that was like a 6-pin for the memory VRM, three six pins for the vCore, then a 6-pin for the car, and it was just like, okay, no, that's too many damn power connectors. And there I actually ran a 12 volt wire to the PCIe slot to get the card to not need that. But here it's just like, that's not necessary on this card, because on this card I actually figured out how to get the memory VRM to fire up. And the trick to doing that is if we zoom in, you see this right here, these unoccupied pads. So normally there's a transistor right here, and that transistor is used to pull low the enable line for the memory VRM voltage controller right here. So normally, like, this basically has a pin called enable. If that pin is not at 3.3 volts, the controller doesn't turn on. And that's controlled by a transistor over here. And potentially some other stuff elsewhere, but the main thing is, like, this transistor, if you just remove that transistor, you force enable that controller, so your memory VRM will always turn on. Now, there's risks with doing that in, like, you could screw up your power sequencing, but I'm not aware of any power sequencing concerns on GTX 480s. On something like a 1080 or a 1080 Ti or something like that with, like, GDDR5X or GDDR6 or HBM GPUs, there are power sequencing concerns where if your VPP rail is lower than your memory rail, you're going to reverse bias your memory and it's going to potentially immediately destroy it. At least according to the data sheets, it should immediately destroy it. not tested that myself, but yeah, you really don't want that. So like there, you really wouldn't want to do something like this unless you know for a fact that your VPP rail is already working. Because if you did something like this and your VPP rail wasn't working and your memory VRM turns on and your VPP sits at 0, dead memory. So that's kind of a concern, but this is a GTX 480, so it doesn't have a VPP rail, so you can just force enable the memory VRM, and yeah, it works. So that's great. This trick also works for 290Xs, but I've forgotten where that transistor is located on a 290X. But yeah, that's one way to like force enable VRMs on basically anything. Is just there's going to be, and I think this is like as far as I can tell, this is standard practice for all GPUs, where it's just like the minor rails and actually even the main rails. There's going to be a transistor somewhere which controls the enable signal. If you just remove that, bam, the VRM will run no matter what. So that's how I got the memory VRM working on this one. Because I did do a GTX 480 in the past where that one unfortunately died because the core was bad. So that was a card that was baked back to life once already. And basically after I e-powered it, it worked for a bit. And then one day it just stopped working. And I was like, okay, well, screw it. I'm not gonna keep using a card that's that unreliable. But yeah, on that one, I didn't manage to get the memory VRM to fire up. So I had another power board for that. Anyway, the last thing that you need to mess with is a transistor over here, which we can zoom in on again. This camera is freaking awesome. So, yeah, this transistor right here, as you can see, I've removed it. You can also see the mess that I made when I was removing it. But yeah, so this is for the Pex controller. I think that's this controller right here. And that might actually be a buck converter, because there's an inductor there, and then we have our bulk capacitance. So, yeah, anyway, but basically... this generates a 1-volt rail, which is used for the, well, it's called PLL and PEX, depending on which manufacturer's GPU you're looking at. But basically, it powers the PCIe interface and some other things. If this doesn't turn on, card doesn't turn on. So again, you just remove a transistor, bam, force enables that. And you don't have to worry about, you know, the fact that the controller's missing. So the last thing I did for the e-power is I did actually desolder the original vCore controller. I don't think that's particularly necessary. But on a lot of cards, that's like the easiest way to get everything else to fire up. But on this card, I also removed the transistors because I already did a GTX 480 once before, and there I had all of the transistors removed, and that worked great. So, well, I didn't have the memory removed because I didn't figure it out at the time. But on this card, you know, yeah, this thing works great, and transistors removed, controller removed, and... yeah, also we have this capacitor over here. This is just a 16-volt Nichicon capacitor. And this is added because normally, if we look down the edge here, actually, yeah. So you can see that inductor over here, right? This inductor, that orange wire over there, that's the inductor. So normally there's a bulk capacitor right after that for plus 12 volts. Obviously that didn't fit because that's, you know, this style of capacitor, which is really, really tall. So that doesn't fit under the e-power. So I removed that, put a new capacitor on the back here. Then these little bulk capacitors, these I added because normally on a GTX 480, you actually have bulk capacitors that would be sort of in this area. And yeah, I removed all of those to make more space for my ground wires, to keep my ground wires as short as possible and as straight as possible. Well, they're not really that straight, but, you know, just get the ground more get the grounding as good as I wanted to. So I had to remove all of those extra capacitors that are on the front. And after that, I was like, well, I don't, you know, we all know I like adding capacitors. I'm not a huge fan of removing them unless it's on a dead GPU and there's some nice SMD aluminum polymers that I'd like to salvage. So in that scenario, so with this card, I was like, well, I'm not really too pleased with myself for removing all of those, though it does make, you know, it does make the connection far more convenient and easier to do. And I'd actually say if you are going to be e-powering a GTX 480, you should just remove them. Like it makes things so much easier to do. But the thing is, after I removed them, I was like, well, I don't feel so great about that. So I have a bunch of aluminum polymers just lying around on my desk all the time because I add capacitors and remove capacitors all the time when working on various GPUs. Because this, in my opinion, is like one of the easiest modifications. E-power, definitely the hardest because, you know, there's a bunch of controllers you potentially have to trick into working. There's You have to deal with the freaking 6-pin and the 8-pin. Then you have to deal with getting proper ground and vCore connections. But capacitor modding, very easy. You just need to make sure that you're putting the capacitors on the output of the VRM and that they're oriented the right way, right? There's not really much else you can screw up about it. So I have a bunch of these lying around on my desk all the time, and I just grabbed a bunch and, grabbed whatever ones I saw and quickly added them on, because just in case that they were necessary, well, they're back on there. The thing is, like, obviously we have the output filter of the GPU now is actually a combination of what we have on the e-power and what the GPU normally has on its own. But the thing is just like, this is potentially, like, these capacitors are sitting behind my crappy soldering and all of these wires. So it's like, I'm not sure how effective these are, because any parasitic inductance or extra resistance between the capacitors and the GPU core is just going to make them less effective at filtering out the switching noise from the GPU core. So because of that, I'm just like, well, yeah, we'll just add capacitors directly to the card just in case, right? Like, and it's not like this will hurt anything. The e-power really couldn't care less. Like, I'm pretty sure we could more than double the stock capacitance from the e-power, and it would not care at all about it. So, yeah, that's really great. That, so that's why I added those. I think that pretty much covers everything. Oh, there's also these extra capacitors over here on the memory VRM, but I don't remember the memory actually improving in terms of overclocking. So, yeah, that's the GTX 4. Like, that. This is my most successful e-power, where it's just like we don't have a ton of voltage drop. The card still overclocks like it did when it was on its own stock VRM. What else is there? Like, yeah, it's relatively neat and tidy. I mean, unfortunately, it is slightly taller than like 2 slots, which if I wanted to run like a 4-way setup, that would be a issue. But I currently only have 2 GTX 480s. The other GTX 480 I have is actually like, I at this point, since I've done this one, and the other GTX 480 I have is not exactly a reference card. It's a semi-custom, like, it's loosely it's based on the reference PCB, but it has a bunch of different MOSFETs on it. But since this was so easy, at this point I'm like, I really want to do that one as well, because I actually don't really like the VRM on the other one that much. That card has like weird that card has some weird issues when it comes to overclocking. Like, it doesn't scale with voltage properly, whereas this one does really well. So I'm thinking with the other GTX 480, I'd like to e-power it as well, because, yeah, this card just, like, this was super, super easy. The main issue right now is just, like, I don't really have another big e-power like this, well, I have an e-power 5, but I was kind of saving that for different projects, and I have a couple power boards, but it's just, like, I was saving the nice ones for e-powering something like a GTX 590, right? Not another 480, so... Yeah, but I can run this in SLI with the other card. So I'm really happy that this turned out so well. And yeah, like, GTX 480, like, yeah, I'm just pleased with how this works out. So at this point, the only things that are really missing is, like, well, arguably I should have a volt mod for the memory voltage, but I can't really be bothered with doing that. I'm just happy that the vCore's e-powered at this point. And the other thing that I should do is I need to get some voltage measurement wires for behind the actual core. So, yeah, that's the only addition. But other than that, like, this is this is pretty good by my standards for e-power. It doesn't drop a bunch of voltage. It doesn't take up a ton of space unnecessarily. It's relatively clean. There's not like a bunch of, like, I've had some e-powers where there was a bunch of like little wires running around just to get stuff to work. And here it's just like, yeah, just remove the damn transistors, bam, sorted. And of course it clears that thermal right air cooler. So yeah, I'm super pleased how this turned out. And now it's just a matter of getting like liquid nitrogen or dry ice for it, and running it, seriously in some benchmarks, because well, like 3D Mark Vantage, I'm still going to do Firestrike just because I always do Firestrike, right? Like, it's my favorite benchmark ever. But yeah, I really want to run Vantage on it. Maybe 3D Mark 11. 3D Mark 11 has one problem where it's just like I suck at 3D Mark 11, so I don't tend to run it very much. Unigine Heaven Extreme, And yeah, so I just need to get liquid nitrogen for this. And I also want to run it in SLI with that other card. And I think for the other card for now, I think I'll just throw that one on, like, throw both of them on, like, dry ice or something. Because dry ice, you don't really have to mess around with, like, mess around with really anything. The other card, I think, I'm thinking, because I do technically, I'm trying to think, I think I'll e-power the other one as well, just for the hell of it. But there's other things I need to do to the other GTX 480 as well, because that one has like a bunch of glued-on heat sinks that I need to remove first, and yeah, I don't have the right solvent for that yet. Anyway, yeah, so this is how you upgrade the VRM of a GPU with a not good enough VRM to start with. And GTX 480s aren't well, they're good for practice because they're easy to do. Well, I don't know that it's good for, well, no, I think practice would be better if you were doing like a hard card, but like GTX 480s are nice to do just because they're like simple power plane layouts and everything, and then it's just remove a bunch of transistors, bam, card works. But the other thing with the 480 is just like, well, it's also cheap, so yeah, but it's not an ideal candidate because there's a lot of cards, like the VRM on this is actually not that bad. A card that would be far more, that would need that needs a e-power far more is like a GTX Titan Kepler, or a GTX 780 Ti reference card, or a 980 Ti reference card, or a Titan X Maxwell, or a Titan X Pascal, like the original Pascal Titan, not the later Titan, because it's kind of funny between those two Titans. One of the biggest difference, like, one has more cores, but it also has like twice as many MOSFETs in the VRM because, yeah, that one's a post 1080 Ti card. But anyway, yeah, just wanted to sort of share this because this is the most successful one I've done so far. And now that I've done this one, I mean, well, I still need to bench this one and do that. But once I'm done with this one, I think I'll move on straight to like the GTX 590. I think. Like, I'll just do a GTX 590 at this point, because I think I have 3 GTX... And oops, sorry for hitting the mic. How many GTX 590... No, I have 2 GTX 590s. I still need to bench those in SLI. But, yeah, once I'm done with everything I want to do on, like, stock GTX... Actually, I think I might have 3 GTX 590s. Why do I not know how many GTX 590s I have? That is a problem. I don't think I have 3. I think I only have 2. I'm pretty sure I only have 2. So yeah, but I do want to do a GTX 590 e-power, and for that I want to use the... Because this uses a bunch of international rectifier direct FETs, and it's a nice 14 phase, but I actually have a Galax Hall of Fame power board, and that's a 16 phase using a bunch of 3555s. So that thing is like insane. It's basically like, so yeah, that power board's like even more powerful than this one. And so I want to use that Hall of Fame board on the GTX 590. And yeah, now that this was successful, it's just like, yeah, probably going to build a 590. And somebody's going to be like, BuildZoid, why do you have no footage of building this thing? Well, to be completely honest, I wanted to build I wanted to e-power and relax. And I can't e-power and relax while a camera is recording it. So that was that. It was just like, yeah, I wanted to build a power, just because the thing is just like, I do actually legitimately just enjoy modding GPUs for the hell of modding GPUs. Yeah. So that's that. That's it for the video. I think I've said absolutely everything I wanted to say. Oh, wait. Thank you to the fans of the channel who, sent in the GTX 480s, because as I mentioned, there was a second GTX 480 with the core that kept dying. So big thanks to that guy for sending in the first GTX 480, because that's like, well, that's the one that led to this one. Because after that one failed, another fan of the channel was like, BuildZoid, I want to see you succeed, so I'm going to send you a known good GTX 480, or relatively known good GTX 480 with no history of being baked back to life. And yeah, that's this card here. And here we finally have a successful GTX 480 power. And I bet now that I've recorded a video about it, it's up and died again. So which would really suck. But no, I think it's fine. So yeah, big thanks to both of them for sending in the GTX 480s. Because these are actually like, honestly, GTX 480s are awesome to overclock. Like these things come at stock 700 megahertz. Like I had no idea how low the stock speed for these was. So yeah, these ship at 700 megahertz, and it's just like you can bench. Like when this was on the reference PCB, I could bench it on 969, right? Like that's a pretty intense overclock. You just don't see overclocks like that these days on all the modern GPUs. Like everything post Polaris, in my opinion, just sucks. Like, and Polaris really isn't a champion of like GPU overclocking anyway, but it's just like a lot of the modern architectures are really boring. They don't scale with voltage. They don't really scale with anything. They don't overclock very much. They have a bunch of stupid restrictions on them. You know, we need more GPUs like the GTX 480. No stupid boost algorithms. No, not just nothing. Just raw power. Very much just raw power. Anyway, so yeah, that's it for the video. Thanks for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. And if you'd like to support what I do here with actually hardcore overclocking, I do have a Patreon where you can support me directly. Or if you'd like to buy some AHOC merch like stickers, posters, shirts, socks, hoodies, there's an AHOC Teespring store. And you can find all of that down in the description below. There's a link to it. And yeah, both of those help out immensely with running the channel. So yeah, thanks for watching, and goodbye.